Okay. So three onwards. Okay, so today we will see the new topic about the selectivity in free radical reactions, bromination versus chlorination. And in last lecture, we have seen that the how we have to carry out the selective bromination by using N-bromosuccinimide. Okay, so with in all reactions, we cannot use bromine, concentrated bromine for the bromination. So whenever we are carrying out the bromination of allylic group and benzylic group, so benzylic methyl group and allylic methyl groups. So for selective bromination of those methyl groups, that means disconnection of allylic homolytic cleavage of those CH bond and substitution by this free radical by the bromine radical, we have to use N-bromosuccinimide for the selective bromination of the benzylic and allylic radical. Okay, so now today our discussion point is how we can carry out the chlorination and bromination, or which factor favors the bromination over chlorination. Okay, so that one we will see in today's lecture. So here you can see on this slide, so statistical and actual analysis or percentage of formation of different types of chlorination, whether we are getting monochlorination or dichlorination or regioselectivity in formation of the product. So here in first slide you can see, so for chlorination the reaction is selective for secondary CH over primary CH by factor of 55. 55, that means 3.6, ratio is 3.6 to 1. So here you can see in case of isopropane, which is on chlorination with Cl2 photocatalytically at 25 degrees centigrade, that means at its room temperature. So the formation of alpha, that means alpha methyl group, that means terminal methyl group, it undergoes chlorination formation after chain initiation, chain propagation, and after chain termination reaction. So finally what we got the product. So here you can see the formation of primary free radical first is here, and that primary free radical does react with the chlorine free radical. Okay, so in that way we do get here primary halides. Okay, primary halide compound in first as one product, and second product is the secondary halogens. Okay, so here the how we can go for the which compound is major and which compound is minor. So here you can see, so primary halides formation is 75% and secondary halogen formation is 25%. Statistical, that means expected, but actually what we get that 45% this primary halide and 55% this is secondary halide we got actually in our hand. So this is meso compound, that means it's like 50-50%. It's a meso compound you got, there is no selectivity at all. For bromination, the same reaction we can observe in case of bromination, that so you can see here selectivity. Okay, so here is comparison, why is bromine is more selective than chlorine. That means here you can, by observing this reaction, the same reaction, propane and propane on treatment with the Br2 liquid bromine photocatalytically at 25 degrees centigrade, that one is giving same primary halide compound and secondary halide as a product. So if we will statistical analysis to get the product is the same 75% primary halide and 25% secondary halide. But what is the real scene, or what is the exact scene is actually you are getting primary halides in 3% as a 3% as a product, and selectively you are getting secondary halide as a 97% as a product. That means its yield, 97% yield is relatively it's too higher. So we can say the selectivity of bromination reaction is higher than the selectivity of the chlorination reaction. So we can say bromination reactions are easy to carry out with higher selectivity of the product formation, secondary halide formation over the chlorination. In chlorination, you have observed that both components, primary alkyl halide as well as secondary alkyl halide, both you can observe in 50-50%. So it's almost 45%, 55%. That is the almost 50-50%. You got the product. So what are those factors which are responsible for the bromination reaction? Okay, so why the bromination reactions are more selective than the chlorination reaction? Okay, so this is our task to get understand. So behind this one, behind all these organic reactions, there are a lot of thermodynamics things, kinetic things, they are hidden, and we have to go for the how much energy involved in breaking up CH bond. Okay, that means formation of primary alkyl halide, how much energy we need. Formation of secondary alkyl halide, that means formation to homolytic cleavage of the CH from the middle carbon atom, how much energy need to break that one, and it depends upon the energy needed, and that's why the formation of those products, these vary in ratios for chlorination as well as in bromination. Okay, we'll shift for the next slide. Now the selectivity. Okay, we are going to concentrate only on the selectivity, why bromination we are getting selectively as a major product, and why chlorination is not giving a selective product, it's giving always meso compounds. Okay, meso racemic mixture, why that one is giving racemic mixture. Okay, next one. Now if you will pay attention on the product formation, here you can say okay, so the selective generating step is breakage of CH bond, homolytic breakage of CH bond by a halogen radical. That means first initiation stage, you may be you are now quite familiar with the initiation stage. In that one, you do get, that means first initiation stage is nothing but the generation of Br dot or Cl dot from the Br2 or Cl2. Okay, that is the initiation stage, and once you got Br dot or Cl dot, you can use that one for the next propagation step. Okay, in propagation step we have seen there are we divided that propagation step in first and in second step. Okay, so in first step what is happening, why is bromine more selective for the secondary carbon than chlorine? Okay, so here in first reaction you have observed this secondary halide. Okay, secondary halide formation is 97%. Okay, that means bromination is selective for the secondary free radical. That means secondary free radicals is reacting in faster way to form the secondary halide, and how that one is forming secondary halide, why that one is forming in faster way, and why that one is reacting to get the 97% of the bromo compound. That one we will see one by one. What are the factors responsible for the selective bromination for the secondary radical? Okay, so here the selectivity determining step is breakage of the CH bond homolytically by a halogen radical. So rate determining step is nothing but the we have to cleave secondary halide, that means secondary, we have to generate secondary radical, and that cleavage of CH bond homolytically, that is the rate determining step, and on that step everything is depends. Okay, so here you can we have generated secondary radical, and here we have generated primary radical. Note that again and again I am telling, as like carbocation can to achieve more and more stability, carbocations they do change their positions, they can delocalize on different carbon atoms or different atoms to achieve the more stability. So in like carbocation, we cannot say the free radicals to achieve more stability, free radicals they do change their position. So free radicals, once you got second radical will remain as it is throughout your reaction, and if you got primary radical at the propagation stage, you will get the primary radical throughout your reaction. It won't getting change, it won't achieve the higher stability by shifting the free radical. So it's not possible in case of free radical. Okay, next one. Now we will go for some, that means energy calculation, how much energy we need for primary radical, primary isopropane radical, primary or secondary radical, and how much energy we needed. Okay, so here in this slide, chlorination to give chloropropene. Okay, secondary radical generated over here, second radical, okay, chlorine radical, that one is generating secondary these alkyl compound free radical, and the remaining chlorine dot, that one is getting reacted with H dot, whatever, that one is homolytically detached from the your isopropane, N propane, sorry, not isopropane, it's N propane. Okay, so bond form, HCl bond has been formed, so energy needed to